Okay, so now we're going to be exploring how we are going to do gradients. So here we're asked, find the gradient of this following scalar field. All we have to do is first set up the following equation. Now from previous video, this was given by the following. Like so. So what this allows us to do is to first, we have to consider computing the partial derivative in each direction in order to assemble it together to find our gradient. So we'll do that step by step. So the partial derivative with respect to x for this given function is going to be 6xy plus z cubed, and using the chain rule, we keep e to the xy. And in this case, because we're taking a partial derivative with respect to x, y is our constant, so we get y out of it. Then from here, everything except for x is going to be treated as a constant. So we have minus 2x, and I'm going to shift the placement of the variables, ln of z. So that's for our partial derivative in the x direction. Now, just to simplify it a little more, 6xy plus z cubed e to the, or I'm just going to do this. Okay, then we have 2xy ln of z. Next, we're going to then compute in the y direction. So as given before, we now compute the partial derivative in the y direction. So in this case, we have 3x squared plus, so instead of now treating x as the variable, we're treating y as the variable. So we're going to get z cubed x e to the xy. Then lastly, we have, I'm going to shift these variables around, x squared ln of z. Because when we act on this part, this goes away, and we get this as our remainder to treat it like a constant. Now, we then have partial derivative of v with respect to z. So in this case, the first term disappears because there's no z. The second term, we have 3z cubed e to the xy. And lastly, we have minus ln of z x squared y. So this gives us minus x squared y divided by z, because the partial derivative of ln of z is just 1 over z. Okay, so now we're ready to assemble our gradients. So just to make it a little easier to see, we're going to assemble our gradient row by row. So in the x direction, we have the gradient of v is going to be 6xy plus z cubed y e to the xy minus 2xy ln of z in the x direction. Then we go into the next row. So it's going to be 3x squared plus z cubed x e to the xy minus x squared ln of z. Just to keep it consistent, I guess I should write z. Okay, so we have this in the y direction. And then lastly, we have 3z squared e to the xy minus x squared y divided by z in the z direction. So as such, this becomes our gradient acting on the scalar function given above. for in the x, y, and z direction. We could do more examples, but the formatting is really systematic. We just have to find the partial derivative in each direction, and then we combine them all together and perhaps display them row by row. In the next videos, we're going to be doing a divergence example and a curl example. All right, thank you.